only hit once. Yeah, I mean, you look at so it's not injective, right? It's not injective because we are mapping negative numbers on the same number. So, but if you would restrict it to positive numbers, it would be injective. So, yeah, it's not injective and not surjective. So you're right. Yeah. Okay, and now we just mapping a number to the identity. So what is this?
Bijective.
It's bijective. Not usually have it in common, right? So, okay, now if we map something to x to minus x, is this still bijective? Okay, so what about 0?
Still 0.
Good. Yeah, exactly. So I mean, minus 0 is the same as 0, right? So that's the difference. So of course it's also bijective. Every letter of the alphabet projected onto the subsequent letter, and that wrap around, so projected to A. So what's this? Bijective. Yeah, I mean, I would agree. So, yeah, I mean, actually this, if you have heard about the Caesar shifter, so this actually, so at the time of Caesar, so in Roman times, like 2000 years ago, so it was some kind of encryption, so they just moved every letter by exactly 3 items, and then it was called the Caesar shifter, and yeah, you might argue it's not very secure, but at that time, most people were not even able to read and write, so it was still some kind of encryption. Yeah. Okay, now if we have, again, x projected to x squared, but now we are not in the integer world, but we have natural numbers. So does this make a difference?
Injective.
Yes?
Injective.
Injective. Yeah, and so that's surjective, yeah. Because non-square numbers are still not injective. Okay, now we have the set of 0, 1, 2 projected to the set of 0, 1, 2, 3, and still it's the identity. Now what's this? Injective, you say. Is it surjective? Can't be, right? I mean, the cardinality of the destination set is larger, so it's just impossible that it could be. Cannot, on this set relation, you cannot have surjective. Yeah. Oh, okay, I don't have this. Okay. I mean, it's obvious, right? So, okay. Describe what the map function, the map reduce is used for. Who could just describe it in his or her own words? Yes?
It just performs like the identical mathematical operation on all elements of the set, like the same one.
Exactly. And what about parallelism? Is there something special about parallelism with the map function? Yeah, what I said is that it doesn't tell you, you don't tell the framework how to actually map it to parallelism. So it's down to the framework to actually decide how the problem is divided. So you only define the mapping, but you don't define how it is actually parallelized. Yeah, mapping a data element to the result of the calculation, which is to be performed per data element. Describe what the reduce function is used for. Yeah, who wants to describe what the reduce function is used for? Yes?
It just aggregates the results of the previous parallel calculations, so it aggregates the results of the main function.
Exactly, and is it done on the Is it done across the entire cluster, or is it done on an individual node? Can actually be both, because I mean, first you can data reduce on an individual node, but then of course these intermediate results still need to be aggregated on the cluster level. Yeah, so imagine the results of the calculations of multiple nodes, but it's also able to define a separate function in MapReduce which only works on the node level and it pre-aggregates on the node, and then the reducer comes in and aggregates on the cluster level. Describes the split, apply, combine principle. Yes?
Split the data set into group and then apply function universally to each group and aggregate of all the results to a single overall result.
Exactly. So the very idea is that you're applying a function to individually to each group, and of course the group can be by your custom user-defined category, and then finally the intermediate results are combined. Data are split by defined criteria into groups, so that is the split. Functions are applied group-wise, that is the apply step. And the results are merged into a single overall result, so that's combined. Why is there a shuffle step between the map and the reduce step? So what must happen in order to be able to reduce something? Sorry?
So like some, let's say there are 3 nodes, and then some node the map function produce a lot of data, some node the map function produce barely anything. So you don't shuffle, and one node will do most of the execution instead of if the workload is shared parallel.
Yeah, I mean, basically you just need to make sure that the data actually there where the reducer needs them. So otherwise the reducer just can't do anything, right? So the data's, every time you have like some kind of operation which requires data from a different node, you need to do a shuffling so that the data will finally be moved where the reducer requires them, and then you can do the reduce step, because it involves finally combining results from different nodes. Because depending on the results of the map functions, the data must be redistributed among the nodes in order to be able to execute the reduce operations. The map function works with key value pairs. Is the key being transformed or the value or both? So what is usually the case? What do you want to transform? Yeah, both is possible, but usually you should transform the value, and usually you use the key just as an identity. So you're grouping by the key until transforming the value. But you can also change the key, so it's possible. Both can be replaced, but usually a transformation is only applied to the value. Describe in your own words how the problem of counting a special word, for example, test in a text file, can be modeled in MapReduce. So if you want want to count a certain word like test, how would you do that? You consider how it was done with just counting any word. So I mean, you just need to modify this a little to actually count only certain words.
The text into the key I only care about the key, the word test. Map the text into a set of tests, and then you count number of tests.
Yeah, I mean, basically you just need to skip every word which is not the word we're looking for. So, otherwise, it's pretty much the same. So, as I said, this word count example is considerably easy to understand, but as I said, a lot of other problems are really hard to model to work on Hadoop. So yes, map function splits the input string into separate words. Then projects every word which is equal to the search word or to 1. So it's the only difference to what we have seen in the slide. All other words are skipped. The reduce function iterates over all results of the map function, adding them up exactly like in the solution for counting all words. Okay, describe why the reduce function requires associativity. What do you think?
Associated function, like it does not define order of elements.
Yeah, exactly. So we don't know so actually the framework is determining the order. So and it's doing so based on the resource situation and so on. So you cannot really tell how it is executed until it actually happens. So that's why we want the function to be able to be executed in arbitrary order. And of course, this is only mathematically possible if we have associativity. So, yeah, so the order of unification of partial results is not defined in general. Therefore, different orders must lead to the same result, which is only given when associativity holds. This primary reduced function requires a neutral element. So what's the problem? We don't have a neutral element.
Like the aggregation function in the reducer, it must like contain all the result or nodes. So if they system of some nodes without any data, so the aggregation function cannot be processed.
Exactly. So it might happen that just some of the nodes don't have any data, so they output like the empty set. And of course, we won't want the empty set to somehow affect our result, right? So yeah, otherwise nodes should not get any data to process would influence the result. Why must associativity be given for the value range of the map function, but not its definition range?
Because only the reduced function requires associativity, and reduced function only works on the value range of the map function.
Exactly. Yeah, exactly. So the value range of the map function is the definition range of the reduced function. So basically, that's why, of course, we have this requirement for the value range. Yeah, the values are used as input data for the reduced function. The keys are passed through. Okay, then are the following structures associative? Real numbers with addition. Is this associative? You say yes. Yeah, I mean obviously yes. Yes, because you can just set the braces differently and it still works. Real numbers with multiplication, I guess it's quite obvious, it's also true. Real numbers with subtraction?
No.
No, right? I mean, 2 minus 1 is not the same as 1 minus 2, right? So, yeah, pretty obviously not. Matrices of real numbers with matrix multiplication.
Yes.
Some say yes, some say no. Okay, who says yes?
Why yes? Give the reason.
No one? I guess someone said. Okay. Who says no? Okay.
You can specify a fixed size. For any two arbitrary matrices, maybe we can pick up or we can start by A because I mean may not be compatible.
But I would say, like, I mean, you cannot, A times B is not the same as B times A, yes. But that's, we committed commutativity, right? So I would say yes, actually. Because matrices are linear functions, and the matrix multiplication is the composition of multiplication functions. So it's like we're talking about associativity, we're not talking about commutativity, which is a different issue, right? So A times B is not the same as B times 1, but in this case, should work. Yeah. Set of string with string concatenation, yeah, I guess it's quite obvious. Someone objecting to this, so we're not convinced. Okay. Yeah, I mean, maybe we can discuss this later, but yeah, I'm also very clear what your objections are, of course. Real numbers with maximum function. You say yes? Okay. Anyone says no? So is the maximum function, is it associative? I mean, I would agree. So, yeah, I mean, maximum K and DC is the same as the maximum of the maximum LB and C. By the way, this also applies to minimum function, of course, but it doesn't apply to min max. So if you're taking first the max and then the min, it's not the same as the other way around. So if you combine it, then it doesn't work. Okay, how should the mapper in chapter 6, slide 25, be rewritten in order to solve the problem of task 2F? So remember the problem of task 2F was, yeah, you want to count a special word. But I guess we discussed it already, so we just need to, yeah, we just need to skip any all words except the one we looking for. So it's just the same code, just for single lines. Is the matrix multiplication formally suitable for the reduced operation? Okay, so I heard that some people are objecting that it's associative, but let's assume for the moment that it is associative. Yeah, I mean there would be another requirement, right? So the neutral element. Do you know a neutral element for matrix multiplication? Yeah, the unity matrix, right? So identity matrix, so the one with the ones on the diagonal line and then the zeros everywhere else. So basically, yeah, we know that this matrix multiplication is associative, so we only need a neutral element. And this is the identity matrix, since both conditions are met, and matrix multiplication is suitable for the reduce operation. What management instance in Yarn exists once per cluster? How's that one called? Several managers. What's
Resource manager.
resource manager, exactly. So this is the resource manager. Okay, once per application.
Application master.
Application master, exactly. So don't confuse this with the application manager, because the application manager is part of the resource manager and it's also exists once per cluster. But the application manager is there to coordinate all the application masters. So we have one application master for each application. So always have as many application masters on the cluster as we have applications running on the cluster. And finally, once per node, node manager, exactly. So we have the node manager. And yeah, of course, these three are somewhat in the hierarchy. So the resource manager is able to actually control the application master, and the application master is talking to the node manager until directed used by the resource manager. So the node manager is only responsible for a single node. But on a single node there may be several containers, right? So yeah. Why are there often multiple containers running on a single node? It would be easier if there was exactly one, right? So why are there multiple containers? You would have less overhead, right? If we have only one container.
Better utilize resource. So, like, if we only have one container per node, then maybe some application runs that use very little of the resource, but it will take that very high node.
Yeah, exactly. So we usually you have like a lot of resources per node, because usually a cluster, as I already said, a cluster works better if we have fewer nodes with more resources than you have many nodes with small resources. So because yeah, the locality is better on the first one. So moving resources between nodes, of course, is expensive compared to with moving data around in the RAM, right? So what you would, in theory, the best cluster would be no cluster, but just a single machine with an unlimited number of cores, right? But that's the reason why we have clusters is that these machines are not there, right? So they cannot just scale up the number of cores infinitely, so, for infinite number. So that's why we need clusters. But of course, we want to have very powerful machines, and therefore, if we do have powerful nodes, then of course we want to maximize the resource distribution as on a single node. This is by far more efficient than just distributing it across the entire cluster in order to keep the load low on the level of the individual node. So your goal should always be to actually put a heavy load on all nodes. So you're doing something wrong if loads are not don't have heavy loads, and either you don't need a cluster at all, or you're doing it wrong. Because you need as few nodes as possible, doing as much load as possible. Yeah, so single container does not grab all resources. How does the resource manager decide where to place the container which is being requested by the application master? So what's the criteria of the resource manager to decide where to place the container?
Like what you mentioned earlier, the application master.
Yeah, I mean the application master requests the running of the container from the resource manager, right? So the resource manager actually decides where to place the container. The application master can only request, hey, dear resource manager, I want to run a container. Then the resource manager says, okay, let me look. Or okay, I guess you should run on this node. Now please talk to this node manager to get the container. So that's the workflow. So, but the resource manager doesn't do this arbitrarily. So it has some criteria where to place the container. And this is done by the resource manager rather than the application master, because the resource manager is available of the overall situation in the entire cluster. So it knows exactly the resource distribution because it did the distribution itself, right? So that's why it knows about the distribution across the cluster. But what are the criteria where to place the container? As I said, the container can be placed on the same node as the one where the application master resides, but also a different one. But what were the criteria for the resource manager to do this? Do you still remember? Yes?
I think it might just depend on the resource availability and maybe also on like where the data is located.
Exactly. So first, of course, the resource must be there. So the resource manager would not denote a node where there is no resource available. So the container must be possible to run this container, of course. And then we have to, by default, the criteria is data locality. So it's looking where the data is located, which is to be processed, and then it will prefer to actually suggest this node where the data is located. But you can, as I said, you can change this behavior. You can say that you want the resource manager to prefer running a container on the same node as the application master, or you can also say, I want it exactly to be run on a different node than the one where the application master runs on. So you can change this behavior, but by default, it's looking on resource availability and data locality, which I think also makes a lot of sense, right? So, and of course, or not of course, but as I said, it can happen that an application master requests more containers from the resource manager than it actually will get. So it can, maybe, not always it will get what it wants. So it can happen that your cluster runs out of resources. So in this case, you will have a queue. So the application master will have to wait until the resources are given back. So the resource manager, of course, will be notified by this. And then you finally, as an application master, you might get what you want, but not immediately. So, of course, all new resources which are available can be occupied, right? And the resource manager is the central instance which actually is aware of all resources or resource usage on the entire cluster. Yeah, an interesting thing is that this kind of architecture, well, in the first version of Yarn, it was more simple, like you had some of these roles combined into one. And it turned out that it's kind of a bottleneck, because actually it's still the case if you're using the standalone mode of Struct, which I'll come to later, so you don't have to use Yarn, you can use another resource manager. And Spark has its own built-in resource manager, which is basically just uniting everything Yarn does into one single instance. And of course, for small clusters, it still works, but it doesn't scale perfectly. So that's why they actually did this separation of all the source, which looks like kind of convoluted and a bit complicated. But the idea is always a decoupling of tasks and responsibilities. So they don't want to have the same instance library controlling applications as the one which is controlling the resources, because then all applications running on the entire cluster would talk to the resource manager directly, which would not scale up very well. So the idea is that we have this architecture, we have a decoupling architecture, and only the instances which need to talk to each other are actually talking to each other. It's not all running through one single node. As I said here, so by default, based data locality, however, can be altered by configuring so-called placement constraints. Which container is not only allocated, but run by the resource manager itself, rather than by the application master, and why?
Application master.
Yeah, exactly. So I mean, it's obvious that well, if the application master is also running within the container, then someone must run this container first. So otherwise we would, of course, run into this chicken and egg problem. So I mean otherwise the process of contacting the node manager requires that there's already an application master and resource. So the resource manager will allocate the first container without an application master to actually run an application master there, and then the application master will ask for the resource allocation of all subsequent containers it wants to run operations on, and then only the resource manager will only direct node managers to the application master, so then the application master can talk to the node managers and get these resources by sending its container launch profile. Okay, so a little bit complicated, but as I said, there are some really good reasons why they have chosen this architecture. And that's why it's also being maintained for Spark as well. So as I said, you can also run Yarn with Apache Spark, which is slightly different in a lot of ways, but still it uses the same interfaces, and it's actually based on the Hadoop interfaces. And also can be run with exactly the same resource managers as Hadoop. Okay, I guess that's it for now. Then thank you for your attention. Then we just meet here at 1 p.m. and continue next time.